there is a slight difference between load testing and performance testing. So in performance testing, we just measure the quality of our web application, and we test it against a normal load. So, and in load testing, we try to break our web application, and we check if current configuration is enough for it to function properly. So these are the some load testing tools available in market. So we have Apache JMeter and Locust, which we are going to see today. So basically, Apache JMeter is pure Java open source software, and it is designed to test functional behavior and measure performance of any web application or web server. And so originally it was meant for testing web application and FTP applications only, but with further updates, now we can use JMeter to test functional aspect and database server as well. So basically, JMeter will simulate real user behavior, and it will perform load and test performance and load testing on any web application or web server. So here are some advantages of JMeter. So first, it is an open source license, so it's free to use, and then it offers friendly GUI where we can configure and maintain our test plan. And it is platform independent, so we can use JMeter on Windows OS, Linux, and Mac OS as well. And it provides visualized test result, which can be in format of CSV and JTL, and also we can generate HTML reports using JMeter as well. It's easy to install. Just we need to download Apache JMeter binary file, and from bin folder we will get a JMeter batch file for Windows application, and JMeter.sh file, which is Linux executable file for Linux OS. It offers simulation, like I said, we can concurrently test thousands of threads using JMeter in distributed manner, and it also offers record and playback option, where we can record user behavior and we can test that particular behavior, load test that particular behavior using JMeter. And it also offers script testing, by we can integrate JMeter with Selenium as well, and we can write down scripting to use JMeter, and with other scripting languages also, like Bing Shell. So this is basic workflow of JMeter, like how JMeter works. So it basically create one request to target server, and while server respond to that particular request, it will save the all the responses, like response time, throughput, and other things. And lastly, it will calculate all the data in statistical info, and we can get a test report in different format, like CSV or HTML. So now we'll see what is distributed load testing. So this is the formal definition of distributed load testing. So distributed load testing is running a test on several different computers at a time. It makes possible simulating a large number of virtual users and involve generating a lot of traffic. So basically in distributed testing, we are using multiple machines, which among them one acts as a master and other machine act as a slave machines, and we can increase number of virtual users and threads using this approach. So why the question arises, why do we need distributed testing? So firstly, running load test, it involves a simulation from thousands of virtual users, and it totally depends on your machine configuration. So it is very difficult for a single machine to generate a lot of virtual users, and so that's why we won't be able to generate enough load to test our web application or web server. So we are using distributed approach for that. So here are basic requirements which we'll need for JMeter master slave configuration. And we are using Google Cloud Platform to get multiple machines. Like we will initiate multiple compute engine VMs, and among them one will act as our master machine, and other will act as our slave machine. So the basic requirement is we'll need one master machine and other slave machines. That depends on your requirement, how much you can get, and all machines must be in same subnet, as we are transferring commands from within machines, so it should be in same subnet, and the firewall must be turned off. Also, we need to install same version of JRE, JDK, and Apache JMeter binary file on all machines. So, as JMeter is a Java-based application, so we'll need JRE and JDK. And also, we need to set up a secure socket layer connection between our master and slave machine, as we are transferring commands from one machine to another. So here is the terminology which we are going to use. So master is our master machine, which will control the test and where we execute our JMeter test commands. And slave is our slave machines, which takes command from master, and it will send a request to target system. And target is the web server of web application under test, which we are going to stress test. Okay, now we'll see JMeter master slave configuration in practical. So for that, we'll need 3 VMs. So here I've initiated 3 compute instances. First is JMeter test 1, JMeter test 2, JMeter test 3. Among them, JMeter test 1 will act as our master machine, and JMeter test 2 and 3 will act as our slave machine. So I'm using totally 3 machines in total. So here you can see I've initiated SSH connection, and we'll use our JMeter test.jmx file as our configuration file. So we can so first we need to configure our this .jmx file using GUI only. So here you can see I've created test plan, and here I have mentioned number of threads, like number of users which I'm going to concurrently use. And so I've created this using HTTP recorder. So here you can see the URL which I'm going to use. And now on master machine, first I'll show you. Okay, so here you can see I've downloaded this Apache JMeter file, the current version of Apache JMeter, and I've already configured JDK and JRE in this in all 3 systems. So we need to get into bin folder of Apache JMeter. So here are basic files. So here you can see JMeter. This is a batch file which is UB, which we are going to use for Windows application, and this is jmeter.sh file, which is for Linux OS, and same for our master slave machines. We need to get into our bin directory. Okay, so first step is we need to start our JMeter server. So as you can see, this is our master machine, master VM, and these 2 are our slave VMs. So I'll start JMeter server on that. So here is the command for that: JMeter, sh JMeter server. So this is Linux command. It may be different for other OS. Yeah, so here you can see we have successfully initiated JMeter server, our slave machine. Same will do for other. Okay, so now our slave machines are ready. Now just on our master machine, we need to enter a command. So the command is in this format. I'll explain the command. So yeah, so basically this is sh JMeter. Okay, so sh JMeter /n to denote that we are using command prompt for initiating our JMeter test /t for our JMeter test.jmx file. So this is our JMX file which we configured using our JMeter GUI test plan, and this is our result /l for result file. So we are generating result on .jtl, uh, uh, and using that .jtl file we can generate HTML report as well. /r to denote our slave machine external IP. So here we have mentioned external IPs of our 2 slave machines, which you can get from here. Okay, I think our test is completed. Here we can see we have successfully configured remote engine, and the error is 0%. So our test is done, and now I'll show you a result format, how we can view the result. So the result of this particular test will be stored in result2.jtl file, and using again GUI option, we can generate HTML report. So here you need to select that particular file, and we can generate HTML result like this. Okay, so this will be our final HTML report, and here you can see the result summary and application performance index, the statistics of all our threads, which the request which we have sent, and if the errors, if there are any. So as you can see, JMeter provides us rich result format. So yeah, so now I'll explain how can we do the same thing with Locust. So Locust is basically very easy to use, scriptable and scalable performance testing tool. So in Locust, we just define our the configuration of our test plan using a Python code. Like in JMeter, we used a GUI for that, but instead of using the complex GUI structure, Locust provide, we can just put it in Python code and we can run our test cases. And so using Python makes Locust infinitely expandable. So like we can do the scripting and structure our test configuration like according to what we want, and that makes it developer friendly. And Locust is configured mainly through command line commands, so we need to use command line commands. So here are some advantages of Locust, like so all tests are coded in pure Python, which makes it easy, and it doesn't require extensive resources, and it's lightweight threading, and it is easy to set up, and it's very fast. And we can use a distributor. Again, we can also use distributed and scalable approach in Locust, where we can it supports hundred of thousands of concurrent users. That makes it very highly user friendly. It is again open source, and it provides friendly web interface where we can enter our web server API address and other things. So yeah, so this is the basic structure of how Locust works. So basically, Locust test is a Python program. So here I have put a uh, uh, small sample code. Here we can see it with the @task annotation. We can provide endpoints for Locust. And after creating that particular file, we just need to put that code in locust file.py, and in our current directory, we need to run locust command. So once then it will start locust, and we can point to our 8089 server using localhost. So, and from there we will get locust GUI. So now we'll see distributed load generation, how we can use Locust for distributed testing. So again, same requirements. We'll need one master machine and some slave machines, and all machines must be in some subnet. We need to install same version of Python and Locust in all machines, and that locust file.py, which we were using, which we have created, it must be shared to all master and worker machine. So I will see Locust configuration using the same. I've configured Locust in same machine. So this is our master machine. So here you can see I've copied locust file.py, which contain a sample code, which we are going to use. Locust. Okay, I'll just show you Locust GUI, how you can see. Okay, so this is Locust GUI. So here we can mention the number of users which we are going to do. So spawn rate is the number of users starting per second. Like we can do the incremental approach. And here we just need to mention the host name which we are going to test. And it will start testing. So currently this is not in distributed manner, but it's what it looks like. So if there are any workers, we can see here. I don't know why it's not. Okay, and the same, we can download different types of reports here in CSV format and in HTML format as well.